with the session.
Hello everyone. I hope all of you are doing great. This is Ansuthar from Parul Polytechnic Institute, and I am moderator for this session of all about usage of steam for heating in process industries, the direct and indirect steam heating. So let me introduce you all today's speaker, Mr. Susanto Mukherjee from Indo-Anushka Steam Technologies. Mr. Susanto Mukherjee is the CEO of the Indo-Anushka Steam Technologies. Uh, he is a motivational speaker and student counseling. He is a co-founder, trustee of Lifeline Foundation. Enjoy involved in saving lives on the highway. He is started career with Miss Jyoti Limited in 1994 as a graduate training engineer. Served in different positions, Flag Limited, Miss Kilburn Industries Private Limited, and Miss Spirek Marshall Limited. After as marketing executive in 1999 for the firm Indo-Anushka Steam Technologies. He is about 25 years of experience in the field of steam and thermal engineering. By not taking much time, let's start the session. Over to you, sir.
I hope everybody is able to see me. Good morning and hello everybody. I'm Susanto Mukherjee from Indo-Anushka Steam Technologies. Today's session, usage of steam for heating in process industries, the direct steam heating and indirect steam heating. Well, today in this session, we are going to discuss about one of the most extensively used applications of steam. And contrary to the general belief that most of the students have, it is not about use of steam in turbines for powerhouse. In fact, one of the most widely used applications of steam in the process industry is for heating. And it is this aspect of steam that we are going to discuss today. Let me make it very clear, this session is going to be on the very basics with the aim of introducing you all to the concept of, just a moment, to the concept of how steam is used for heating in the process industry. It is not going to have lots of theories, it's not going to have lots of calculations and all that, no equations and all. Just the basics, an introduction to all the students to this process, how this process of heating takes place in the industry. Anybody who is interested to know more details about this system and discuss more can get in touch with me personally on the phone, on the WhatsApp, by email, etc. All my details are available with the coordinator or moderator or Mr. Suthar. You can get my details from him. Now coming back to the subject, heating basically is a part of most of the chemical processes that take place in the process industry manufacturing. In the process industry, steam is used for heating in two ways, the direct steam heating and the indirect steam heating. Today we are going to understand the basics of both these processes, and let us start with the indirect heating process. Now, heating in the industry would mean heating in a very large scale, not like something that we do at home. Let us try to understand this with a slide. Suppose we would like to make sugar syrup at home, chasni, as you call it in Gujarati. What do? We actually take a pan, put sugar and water inside, put it onto the gas stove and heat it till we get the required consistency, right? Now in industries like say sugar industry, Baroda dairy, the food industry, which is also a part of the process industry, this same heating would be required, and it would be required to be done 1,000 times more, or maybe more than 1,000 times more. So now suppose we try to heat this in the same way as we do it at home by putting a gas stove. See what would it look like. This is the kind of the size of the vessel that is used for heating the process fluid inside. And suppose you want to heat it with a gas stove as seen here. This would be the situation, which is actually just not possible, right? So we will try to understand how the heating is done in the industry. Before that, I would like to actually discuss with you we are using this term process industry. So what is a process industry? To understand that, let us see this figure. A process industry in general is defined as an industry where two or more different substances are mixed together, and then heat is provided, that is heating is done or cooling is done if the process is exothermic, and what we get is a completely new substance, a third substance comes out. Now the sequence of mixing, the time of mixing, the heating time, the cooling time, the sequence of heating and cooling might be different based on the substance that we require. So process industry or a process in the process industry would involve mixing two substances, making it go through a process of heating, cooling, etc., and getting a third substance. Okay, therefore, like we discussed about the sugar syrup, it is also a process in the process industry. Sugar and water is mixed, put inside a container, and it is heated to get the required consistency. Similarly, if we look at another process, we might have learned in our chemistry, calcium carbonate plus hydrochloric acid would give us calcium chloride plus water plus CO2. The equation would be as simple as CaCO3 plus 2HCl is equal to CaCl2 plus H2O plus CO2. Let's not get into those complications. Another process would be like calcium carbonate, which is nothing but marble or limestone you get in Jodhpur and all. If we powder it and put calcium carbonate and hydrochloric acid, that is HCl, inside, they react. And HCl is put in the form of a solution. So they react, and what we get is CaCl2 calcium chloride, which is a finished product in this case, a completely third product, not anything common with calcium carbonate and HCl. This is used as a raw material for many other industries. So what we get by mixing calcium carbonate, limestone and marble, and hydrochloric acid is calcium chloride plus H2O. After we get this, and CO2 is liberated and sucked out. After getting this, we actually provide heat to the vessel to concentrate the calcium chloride and water and make a kind of a paste of calcium chloride, which is the finished product. Both these above examples, the sugar syrup as well as mixing of limestone with hydrochloric acid, are examples of heating used in the process industry. Now, how this heating is done in the process industry? As we saw, we cannot do it by putting a gas stove under a vessel because the vessels are very big. So how do we do it in a process industry? This is the kind of vessel that is used. Now, what we are trying to understand now, as I said in the beginning, is the indirect steam heating. We will do the indirect steam heating first, and then we will go to the direct steam heating. So how do you heat this kind of big volumes of process fluid. So we have a container like this, which is a very big container. They are called the vessels, reactor vessels or vessels. They are provided with another vessel like this, a covered vessel with a gap between the two. This is called the jacket. So there is one vessel, and around that vessel, a jacket is provided. A jacket has about, say, 50 mm or about 100 mm gap between the main vessel wall and the jacket wall. Steam is provided into this jacket, and this steam gives its heat from the jacket to the inside, and inside the vessel there is this fluid. So you want to make sugar syrup, Sugam Dairy wants to make sugar syrup, they will put sugar and water inside here. They will supply the heat through the steam, heat by steam through the jacketed vessel, and this will start boiling, and therefore you will get a concentrated sugar syrup. The same happens with limestone powder and hydrochloric acid, and then heat is provided by steam through this jacket. There are other nitty-gritties involved, like how condensate is removed or steam after converting to water is removed. We'll discuss this as we go into the details of the heating process. Okay, but as you see now, let us be up to the point that now heating in the industry by indirect steam heating is done with these kind of vessels. These are called jacketed vessels, and heating is done by steam by supplying it to the jacketed vessel. Okay. Now, to understand the process of heating, as I said in detail, we need to understand the characteristics of steam, how steam can carry heat and how steam gives away its heat, with what kind of characters. So let us study that in brief so that we understand the process of heating more elaborately. For this, we'll try to understand the characteristics of water. Now, what is steam? Steam is nothing but the vapor stage or the gaseous stage of water. Now, if you have water and you supply heat to water, what you get is steam. In very simple words. Now, let us understand this in a little more detail. If you see this slide, what you see is water, heat, and you get steam. Here it's written at constant pressure. All of you might have already learned that in a pressurized environment, at every given pressure, there are characteristics of water and steam which are specific to that pressure and defined. So whatever we are now discussing is going to be at a constant pressure. It might be any pressure, right? Now, if you put water inside a container, closed container, that with some pressure, whatever be the pressure, and you start heating it. First and foremost, water remains in the liquid state, temperature rises, and heat continues to be added. This heat that is added to water in the liquid state is called the sensible heat. It is named the sensible heat for the purpose of understanding. After this sensible heat keeps continuing to heat the liquid, that is heat water, and temperature rises and reaches boiling point, which is also called the saturation point, and you continue to supply heat, what happens is the temperature remains constant, but heat keeps getting added to water, and the water starts changing its state. It starts changing its state from water to steam. This heat that is supplied at constant temperature to water to change its state is called the latent heat. I'm quite sure you all have studied all this. The latent heat is used for energizing the molecules to break it or pull it apart and change the state of water to steam. This happens at constant temperature. Typically, the experiment that we used to do, thermometer to be put inside the water and heat it, and after a certain stage, when it's open to atmosphere, 100 degrees centigrade for take a bath, the temperature doesn't increase, but water starts converting into steam. We have all learned H is equal to H plus XL, that is total heat, is equal to sensible heat plus latent heat into the dryness fraction. Now, dryness fraction is because Steam is a vapor and it's not a gas, and therefore there will always be a percentage of vapor with the steam. And based on the dryness fraction, you know how much steam and water vapor is there. For the ease of understanding today, we will consider that the steam formed is 100% dry. So we will ignore this X and continue with H is equal to capital H is equal to small h plus XL. Now what happens if we reverse the process? Once the steam is taken and made to get in contact with a cooler surface, what happens? Immediately the steam will start giving away its latent heat first. Once it reaches the saturation point, that is all the latent heat is given away, it will turn into water, and there still will be sensible heat in water, and the sensible heat will also be given away. But what we need to understand here is latent heat is given away very easily by steam. Isliye you see the word here udar and you see the word here conduce. What it means is latent heat is very easily given away, very fast given away. That is, it is given away at a very fast rate. And sensible heat is difficult to give away. So once you have hot water, you will have a very slow rate of heat transfer. So whatever heat is required for heating the cold fluid will be done at a lower rate if you have hot water and you are transferring sensible heat. As long as steam is there and steam is giving away its latent heat, the latent heat gives away heat. The latent heat is given away fast, and therefore faster rate of heating takes place. Therefore, if you go back to the fundamental of the jacketed vessel, you will now realize that steam is used for heating because there is latent heat inside steam, and therefore latent heat is given away fast, and then the water is removed because sensible heat gives away slow. Now most of the industries, they work on the logic of rate of production. Rate of production would mean how fast production can take place. Therefore, every industry is more or less interested in having the latent heat so that heating takes place fast, and removing the water. The steam forms water after the latent heat is given away, and removing that water as soon as possible because sensible heat takes time to get transferred. Now let us get back to the slide of the jacketed vessel again to understand it better. As we saw before, this is the jacketed vessel. Therefore, indirect heating in industry takes place in a way that steam is supplied into the jacket. There is the process fluid inside. This is the cold fluid as we talked. And this is the hot fluid. So as soon as steam comes in contact with this surface, which is cold due to the cold fluid inside, it starts giving away its latent heat. This is called the jacket area. So from jacket area, the steam starts giving away its latent heat. Once it has given away its latent heat fast, what happens is it gets converted into water in this jacket. Now this water is not useful for industries because sensible heat takes time to be transferred and therefore process gets slower. So there has to be a way of removing this water as soon as it is formed. That is done by this module. This module, condensate outlet module, is known as the steam trap module. Condensate is the water which is formed by condensing steam or cooling of steam. That is after steam gives away its latent heat. It's known as condensate, it's hot water. Now condensate outlet module consists of a steam trap as you see here. This is called the steam trap. Now steam trap is an equipment which allows water to flow out but does not allow steam to go out. Now how this works and all is a different subject altogether. If the opportunity arises, we'll discuss it sometime. But at this juncture, let us understand steam trap is a kind of an equipment which will stop steam from going out so that all the steam, until and unless it has given away its latent heat totally to this fluid for heating it, is not allowed to go out, but it will allow water to go out. So as soon as water is formed inside, water will get removed through this steam trap module. Everything else that you see here, like this is the strainer, these are valves, this is a double window side glass, These are all to complement the steam trap. The strainer, so that the steam trap doesn't get choked, the multi-view or the double window side glass, to see whether water is being removed or there is a leak in the steam tank and you are losing steam, etc., etc. So this is how indirect heating takes place in the process industry. Indirect heating means the steam does not come in direct contact with the process fluid, so it's indirect. The steam gives away its latent heat, and as soon as the sensible heat is formed, I mean the water is formed, the water with the sensible heat is removed. Let us see a few more equipments that are used for this kind of indirect heating. You have, say, plate heat exchangers here. Plate heat exchangers would mean different plates put together with a slight gap between the two and then bundled up using these end plates. Now steam passes through one path and the process fluid passes through the other gap. So side by side you have steam one plate and the process fluid, steam one plate and the process fluid. And this is how the process fluid is heated using steam without the steam allowing to get in touch with the process fluid. These are plate heat exchangers, and the main advantage of these plate heat exchangers are that you have a bigger area of heat transfer than the jacketed vessel. There are many plates, so all these areas together, you have a bigger area where steam can keep giving away its heat. Similarly, you have kettles like this. The sugar syrup in the food industries is made in these kind of kettles. Process fluid is poured inside. Steam is used in the jacket. This is the steam trap. And once the sugar syrup is achieved, you just have this handle, you convert this or tilt this and remove the sugar syrup. You have fin tube heat exchangers. Fin tube heat exchangers are tubes that are put inside which has fins to increase the area of heat transfer. And what happens is you have the steam passing through the fin tubes and you have the process fluid passing from the side. All these are vessels. Like this is a jacketed vessel, the drawing of which we saw. This is the jacket and this is the main vessel where the fluid is poured in. All these vessels are used for indirect steam heating because the steam does not get in touch with the process fluid. Now in indirect steam heating, just we need to understand one fact, that once the water is formed, the condensate is formed after steam gives away its latent heat, this condensate needs to be removed and therefore is either wasted along with the heat, that is the sensible heat, or there has to be made arrangements for returning this hot condensate or hot water back to the boiler feed water tank so that you can recover the heat inside recover the sensible heat inside the water and not waste money, because heat is equivalent to money. This is how basically indirect heating takes place in an industry. Okay, now that we have understood what is indirect heating, let us now approach how a direct heating takes place in the industry. At the end of the session, we will have a comparison, kind of a comparison of the direct steam heating and the indirect steam heating to see what are the advantages of two and where can each be used in a very basic sense. Okay, so that was all about the indirect steam heating. Now let us understand what is direct steam heating. Direct steam heating, as the name suggests, is the kind of heating that takes place where steam comes in direct contact with the process fluid. Let us first have a look at a few equipments that will help to make the concept more clear that are used for direct steam heating. Okay, see, this is a kind of a mixer equipment where you have steam coming in from here, you have the unheated liquid, the liquid that needs to be heated, pumped in from here. It goes into a spiral due to this helical flights or the baffles that are given inside. The steam comes out from this perforated sheet and mixes with the fluid and helps it to get heated. What comes down from here is the heated liquid mixed with the steam. Okay. Similarly, let us understand with the help of the graphics. Suppose we want to have hot water. We can heat it by putting steam inside the hot water. Let us see how that happens. You have steam coming in here from the inlet. You have an equipment called a thermoject or a steam injector. As it goes inside the injector, it pushes the fluid, so therefore other fluids come in from the side. The water gets sucked into this one from the side, mixes in here. Hot fluid goes up, cold fluid comes down, the process continues, and slowly the whole water gets heated. Now this is a kind of steam injector. Many equipments like this is available. Like the steam injector looks something like this, where you have steam coming in from here, the cold water getting sucked from here, everything mixes inside and hot water comes out from here. You have similar equipments which are called sparge pipes. You can dip a pipe. Each have its advantages and disadvantages. Again, another subject which we can discuss later. But this is basically the concept of direct steam heating, where steam directly comes in contact with the process fluid and heats the process fluid. Now that brings forth a very important point, that this kind of direct steam heating is only possible where the process permits the mixing of steam into the process. Okay, you cannot have something which you want to concentrate by heating, like calcium carbonate and sulfuric acid form CaCl2 and water, and you want to heat it and evaporate it. Now if you land up adding direct steam heating, you will actually add water into it, right? The steam will give away its latent heat and then there will be water inside. So it won't get concentrated, it will get diluted. So such process won't allow direct steam heating. We will understand at the end of the session that direct steam heating is advantageous. It saves money, it saves energy, but the limitation is you will have to use direct steam heating only where the process permits the mixing of steam with the process fluid. One such major process used in the industry, let me discuss with you so that the concept is more clear. Mainly in pharmaceuticals, there are certain concentration and mixing that is required to be done along with heating, where a very gradual heating is mandatory. To get the finished product of the required quality, a very gradual heating is mandatory, is required. In that case, if you heat it in the jacketed vessel by putting steam, what happens is there is a surge of latent heat inside and very fast heating takes place, which damages the product. So there, water is used, hot water is used in the jacket, so that sensible heat gets into the play and slowly heat is transferred and the required heating is obtained. In such cases, mainly pharmaceuticals, you have hot water generators. You have to generate that hot water. This hot water is generated in hot water generators and used in the jacketed vessels. Now, how do you generate hot water? Let us try and understand. Full screen what? Okay. See, hot water can be generated first. Let us have a look at this. Hot water could be generated by putting cold water inside, as we saw in the jacketed vessel. You will have steam going into the jacket and giving its latent heat and making hot water, increasing the temperature of hot water. In more practical sense, you will have a temperature sensor here. You might require hot water at say 70 degrees centigrade. This will sense as soon as this reaches 70 degrees centigrade, it will send a signal to the controller. This controller will then send a signal to the control valve, which can be a proportionate control valve, meaning it can open and close with increase and decrease of temperature, or an on-off valve, which will close when the temperature is reached and open when the temperature goes down. This controller will send a signal to the control valve and it will operate to control the quantity of steam that needs to go in. Once the latent heat is given away, water will be formed and that water will be removed from the steam trap module or the condensate outlet module, as we understood before. Hot water, cold water will be added from here and hot water will be taken out from here. It can be a continuous process, right? But something that is worth understanding is steam can mix with water without changing any characteristics of water. And therefore, it would be much more advantageous to use steam by directly injecting it into water, because in that process, we are going to use the total heat. Here, we are using the latent heat only and letting the sensible heat go out. Whereas in this vessel, where you can directly inject steam, you can use the total heat of steam. Therefore, for heating the same quantity of water to the same required temperature, more steam would be required here because only latent heat is used, and lesser steam will be required here because the total heat of steam is used here. So this is a hot water generator without a jacket. It's a non-jacketed vessel. Okay. You have these points also, which is worth understanding. Steam pressure is set as per the hot water temperature required. Suppose hot water temperature required is 70, you will have to have steam at a temperature which is slightly more than 70. Say usually it's 20 degree for an industrial gradient. So around 90 degree or 110 degree. So based on that saturation temperature, you have to set the pressure of the steam that is going to be supplied in both the cases. Based on the temperature requirement, the process side may be under pressure or at atmospheric pressure. Even the process side, and this side can also be put under pressure because there is water and you will get higher temperatures of water based on the requirement of the temperature. Okay, but our main focus would be these kind of hot water generators are preferred or should be preferred to have direct injection of steam, because you use the total heat and therefore you will considerably reduce the consumption of steam compared to what you are going to consume if you are using an indirect heating process. Okay, so does this make the concept of direct heating clear? Direct heating is where the steam is directly injected or put into or mixed with the process fluid. Indirect heating was indirect heating where steam is not allowed to get in touch with the process fluid. These are the two kinds of heating widely used in the industry. Now let us have a kind of a comparison with a small calculation. Like we saw in the hot water generator, what happens if we have a process which permits mixing of steam, but we heat it by indirect heating and we heat it by direct heating? Let us try to understand what would be the difference of steam consumption. That we have now understood the basic of what is indirect heating and what is direct heating. Let us see which is more advantageous and what is the precondition with the help of a calculation. How do we put this into a view full screen? Okay, I'll just try to see if I can increase the size. How do we increase the size? Let us see, put it this way. Okay, so let us now try to understand steam consumption calculations. We'll first try to understand the steam consumption if we use the indirect steam heating. Like suppose we take the example of the hot water generation and we have put it inside a jacketed vessel. What happens to the consumption of steam? Now the data that is considered basically is quantity of water that is to be heated is about 5 kl per hour or 5000 kgs per hour or 5000 liters per hour, right? Specific density of water is 1. So let us consider 5000 kgs per hour. The water needs to be heated from 35 degree to 70 degree. And the steam pressure used is 3 kg per cm square gauge. Now for ease of understanding, we have considered steam to be 100% dry. As I said before, so dryness fraction is 100% or 1. Therefore, we have H is equal to capital H is equal to H plus XL. X is 1, so we have considered H is equal to H plus L. That is the total heat of steam is equal to sensible heat plus latent heat. Okay, now all of you, I am quite sure, know about steam tables. For the given pressure, you get these values from the steam table. The sensible heat of steam at 3 kg per cm square gauge pressure is 144 kilocalorie per kg. The latent heat is 509 kilocalorie per kg, and therefore the total heat is the addition of both, which is 653.7 kilocalorie per kg. Now you have to understand, in steam tables the values are given as kilocalorie per kg. So if 1 kg steam is used, it can give away, say, latent heat of 509.7 kilocalories at 3 kg per cm square pressure. Okay, I'm quite sure this concept is clear with you. Now all of us have heard about the equation mST2 minus T1. That is, heat required would be mass into specific heat into difference of temperature. Now if we want to find out the steam consumption, let us consider the indirect steam heating process. That is, only latent heat of steam is used. Therefore, heat required by water would be mass into specific heat of water into difference of temperature required. And this would be equal to the heat given by steam. Now in case of indirect heating, it would be mass of steam that would be required into the latent heat of steam per kg. Okay. So therefore, what we have is 5000 kgs per hour. So 5000 into 1 is the specific heat of water or steam, or specific heat of water, which is 1 kilocalorie per kg of water is required to raise the temperature by 1 degree centigrade. So it is 5000 into 1 into, we needed to heat the water from 35 degrees to 70 degrees. So 70 minus 35. This would be equal to the mass of steam required into the latent heat at 3 kg per cm square. That is 509.7 kilocalories per kg. Therefore, the mass of the steam required would be this divided by this, right? So it would be 5000 into 35 divided by 509.7, which is equal to 343 kgs per hour. Okay. Now, if we try to see the same thing for the direct heating of steam. In direct heating of steam, as we saw in the figure, the steam is directly injected inside the water. So the total heat of steam goes inside the water. In that case, the heat required by water would remain the same. 5000 into 1 into 70 minus 35 is equal to mass of steam required into total heat per kg of steam at that chosen pressure. So that would be 653.7, as we saw up here. The total heat of steam is 653.7 kilocalories. So per kg of steam, you get 653 kilocalories, and mass of steam required would be this divided by this. So 5000 into 35 divided by 653.7 would give 268 kgs per hour. So as you saw above, the steam required in indirect steam heating was 343 kgs per hour. Whereas if I used direct steam heating for achieving the same temperature of water for the same quantity, I used only 268 kgs per hour, which would mean 75 kgs per hour of steam would be saved. We save 75 kgs per hour of steam per hour of steam for the above requirement. Per hour is important. Therefore, if we start calculating, the industrial price of steam is about 3 rupees per kg. I have considered rupees 2 to be on a more conservative side. So if you see and relate it with money, what you'll end up saving is 75 into 2, that is rupees 150 per hour. Or you'll end up saving 75 into 2 into 24, that is rupees 3600 per day. And 75 into 2 into 24 into 365 days would mean 1,31,400 per year, which is a substantial amount. Okay. Therefore, we need to keep in mind that we should use direct heating by steam wherever possible, as it is beneficial, as direct steam heating saves significant energy and money. But Very important to remember that it can be applied only in process where the process permits the direct mixing of steam with the process fluids. For example, we can use direct injection of steam for hot water generation, okay? But we cannot use direct injection of steam when calcium chloride solution is required to be concentrated by heating, because if we do so, instead of getting concentrated, it would actually get diluted. And our whole aim is defeated, okay? So now we know that today steam is the most used medium of heating in the process industry. And we have two ways that it is heated. The indirect way, where you have the jacketed vessel being used and steam heating the process fluid without getting in touch with the process fluid. That's the indirect way of heating. And the second way of heating is the direct injection or direct steam heating, where the steam is directly put into mixed with the process fluid and it is heated. I hope this makes the basic concept of how steam is used for heating in the industry is a little more clearer to all of you. We can have this in a detailed discussion also in some other session, but today my aim was to introduce you to the environment of heating in the process industry using steam, and the two ways are the indirect way and the direct way of heating. I hope this to a good extent introduce you to the concept, and I hope you have understood the concept well. With this, I would like to end my session. I wish all of you to stay happy, to stay safe, and stay blessed forever. Thank you. I think you have a question and answer session now, and the moderator will coordinate the same. I hand it over back to Mr. Ansh, who is the moderator. Hello, Mr. Ansh.
Yeah, sir.
Yeah.
Yes, sir.
I'm open to any questions that might have arisen.
Sir, one question. Steam jet injector are used to pull vacuum on process equipment such as a distillation tower to test process vapor steams.
When I talked about, can I answer? Hello?
Hi, sir. Yeah.
Yeah. Actually, when I talked about injectors, these injectors are used to inject steam inside the process fluid and heat it. I think the question that you asked about is an equipment called an ejector. Ejector is an equipment where steam is used to pass through a orifice, or which is a convergent divergent type of an orifice, and create a vacuum inside the vessel and suck out certain gases. The same principle is used for cooling also, by passing by throttling the process. There steam is not used, water is used. So that's a completely different process. What we are discussing today is about the heating process. And very true, the person who has asked, distillation columns have ejectors. Ejectors are equipments which are used to create vacuum by using steam or water. You have a convergent divergent nozzle and you have a point of suction at the critical area, that is the convergent area. And when the steam or water passes through very high velocity at the critical area, it creates a suction, and therefore it is known, gases or things are ejected out. That's why it's called an ejector. I hope I have been able to answer the query.
Yes, sir. Next.
Tell me.
when water is heated with rise of temperature, if consumes latent heat या sensible heat.
Good question. The basic logic is between the indirect heating and direct heating. As I said during the session, when you are heating the water using indirect steam heating, that is, you are putting the steam inside the jacket. Let me get one of those slides up again. See, when you are using, okay, just a moment. Let me get the slide in place. Just give me a minute, minute, a few seconds.
Yes, sir. Yeah.
Is the slide visible now?
Yes, sir.
Yeah. See, the question is, when we are heating water using steam, are we using latent heat or sensible heat, right?
Yeah.
Yeah. Water can be heated using steam in both the ways, as we discussed. It could be indirect steam heating, like you see in this figure, and the water will get heated. In this case, the steam is supplied into the jacketed vessel and only latent heat is used, and the sensible heat and water is removed using this trap module. But if you heat water, you see this figure, by directly injecting steam inside, then you use both the latent heat and the sensible heat. That is the total heat of water to heat this steam. And as we saw in the calculation, to heat this water. And as we saw in the calculation, if we heat water by this process, directly injecting steam into the water, you use lesser quantity of steam to heat the same quantity of water to the same required temperature as you would have done by using indirect steam heating. You use lesser steam here because you are using the sensible heat plus the latent heat, the total heat. Whereas here you are using only the latent heat. So you can use steam to heat water, and you can use only the latent heat if you heat it by indirect process, and you will be using the total heat, the sensible as well as the latent heat, if you use the direct steam injection. I hope the query is answered.
Okay, sir. Sir, which steam is often used in a steam turbine to prevent damage to equipment caused by the inflow of condensate?
Though this is not the subject which was supposed to be discussed today, but I'll answer the query. Being a man from the industry, it's a very good query. This is some things that we probably do not learn when we are in the college. I've also gone through college and I understand. Well, in turbines, the impeller or the turbine blades rotate at a very high speed. Therefore, it becomes absolutely necessary that no solid particles or liquid particles are present in the steam that drives the turbine. Okay? Because the steam that comes in is at a very high velocity and it makes the turbine blades move at a very high velocity. Saturated steam travels at about 25 meters per second speed. If you have a droplet of water traveling at that speed, it is as good as a bullet hitting the turbine blade, and therefore it will erode. Therefore, adequate care has to be taken for the quality of steam that is to be used for running a steam turbine. For that, saturated steam cannot be used in high power, high RPM turbines. You have to have a completely superheated steam for use in turbine. Superheated steam would mean that after the steam is in the saturated temperature, more heat is supplied to the steam and the temperature of steam is increased furthermore, which is known as the degree of superheat. And it is heated to a level where there can be no traces of any water vapor, water droplets, etc., remaining present in the steam. So mandatory for power turbines is supply of superheated steam. Apart from supply of superheated steam, the water and the steam, that is the water that is used to make the steam, and that the steam that is created from the water is subjected to lots of testing to remove any kind of silica and other such possible impurities inside the steam. So the steam, there are SWAS systems, steam water analysis systems. They are called the SWAS systems in the industry. So the water used, and after the steam is formed, the steam is condensed and tested through these SWAS systems, which tests the conductivity, the TDS, the silica content, and everything. It has to be minimal, tending to be zero, and the quality of steam has to be superheated. I hope it clears the
Yes, sir. Now I would like to invite Ankit Pandya, sir, for thanking note.
Yeah, thank you very much, Ansh, for moderating this whole session. And I'm glad that we had Susanto sir with us today. And I'm very much thankful to you, sir, for providing your time from your busy schedule and sharing the details related to STEAM technologies to all our students of engineering, specifically if I consider mechanical field. And I hope that students have definitely gone through the whole session very well, and they have definitely understood the things which you have shared with them. So with that, I would like to thank you. Thanks to Geeta ma'am as well for having this whole coordination done in between Parul University and Indo-Anushka STEAM Technologies both, because she was the one who is coordinating for all the activities from your side. So I'm glad that we had connected. And thank you very much once again for all the time and expertise which you have provided to our students and the university as a whole. Thank you, sir.
I also thank Parul University for creating this opportunity. It is always a pleasure to be introducing industrial concepts to students. I only hope that this has been a help to all of them to just get introduced to the environment of steam heating in industry. Thank you.
Actually, sir, thanks a lot. We'll be definitely getting back to you for any other questions. If the students are having, we'll definitely get the questions to you on your email if we have any, for sure. And yes, Ansh, thank you very much for coordinating. Actually, sir, I would like to mention that Ansh is right now pursuing his diploma in mechanical engineering, and he is the student placement coordinator right now. He's in the final year, and he's also from mechanical engineering, and he coordinated the whole flow of the program. So yeah, that's a good remark for him as well. Yeah,
and you can get in touch with us anytime you want to. You have any queries, and welcome.
Sure, sir.
Yes,
thanks a lot.
Thanks.
Thank you very much.
Stay happy, stay safe, and stay blessed.
Same to you, sir. Thank you very much.
Thank you.
Yeah.
Thank you.
Okay, bye-bye.
Goodbye. Goodbye.